Welcome to all of you. In this lecture, we are going to discuss about the details of 74192 4-bit presettable decade counter. Also, we are going to have continuation of it with the realization of the up counter as well as the down counter using 74192. Let us first go through some of the details of 74192. So it is a 16-pin IC and a 4-bit counter. So 4-bit counter, it doesn't mean that it can count all the range. It can count only from 0 to 9. Therefore, it is also known as the decade counter or the BCD counter. It can perform both up counting operation as well as the down counting operation. To perform these two separate operations, there are two separate clocks using which we have to perform up counting as well as the down counting operation. So this is programmable in the sense by using the preset operation, the counting can be started from any value within the range. In order to set this preset value, we are going to have separate input data pins D0 to D3. So it is also having two asynchronous inputs, that is clear as well as the load signals. This is what the pin configuration of 74192, and this table is going to provide all the details of the pins provided over here. So first let us start with this one. So D0 to D3, they are input pins. So here we can observe. So here is the D0, then here is the D1, then here is D2 and D3. So these are the input data pins that is used to preset the value. Then it is going to have four outputs, Q0 to Q3. So here it is Q0, then Q1, then Q2 and Q3. So these are the output pins. Then CPU and CPD. So this is clock for up count operation and this is clock for down count operation. So here you can observe CPU and CPD. Then it will have always the ground and the VCC in the IC. So this is the ground and here is the VCC. And then PL bar. PL bar is a asynchronous parallel load operation and it is active low in nature. So whenever we want to load these data values to the output directly, then we are going to make use of this PL bar line. So PL bar is present over here. Then TCU and TCD. So both of these two corresponds to the terminal count operation. So TCU corresponds to terminal up count operation. It is active low, and TCD is a terminal down count. Again, this is also active low. So these two pins are very much useful when we are cascading more than one 74192 ICs. Then MR stands for the master reset. It is asynchronous in nature and it is active high. So whenever we want to reset all the values, then we are going to make use of this master reset. So master reset is over here. Now let us understand the IC representation in a very simple manner over here. So which are all the inputs and which are all the outputs in total, and this is what the diagrammatic realization we are going to make use in any further discussion, right? So here are the input lines D0, D1, D2, D3 and PL. So PL is active low, so bubble is provided over here, and again CPU, CPD, MR, these are also inputs. So totally these pins over here in this area are the inputs, and these are the outputs Q0 to Q3 as well as the terminal count up as well as terminal count down, right? So MR, D0, D1, D2, D3, they're all active high. CPU, CPD, clock signals, they're positive edge trigger. PL, that is active low signal, that is parallel load. Outputs are Q0, Q1, Q2, Q3 as well as TCU and TCD. Again to remember, so PL as well as MR are asynchronous inputs. They are asynchronous in nature. Now this is what the detailed functional table of 74192. So here is the operating mode and these are all complete set of inputs and these are the complete set of outputs. So first we are going to have four different operations. One is the reset operation, then parallel loading operation, then count up as well as the countdown operation. So let us first start with the reset operation. So in order to perform the reset operation, what are all the input criteria? And obviously we are going to get the output as all zeros or all low, right? So in this case, so master reset is the reset operation which will set all the output to the low value. Therefore, master reset is a active high signal. So when we keep this master reset as high, all others will be don't care. These two are don't care. CPD either keep it low or high. So irrespective of the input data lines, the output will go to low values. Anyhow, since we are making use of single IC, I'm not going to make further discussion about TCO as well as TCD. So I'll be stopping my discussion with respect to output over with respect to input Q0 to Q3 only. Right? So then further for parallel load operation, parallel load in the sense whatever the data lines is having the value, those values will be shifted the output. That is what we known as the parallel load operation. In order to operate parallel load operation, we have to make use of the line PL. For that, first set the master reset value to low. Therefore, here you can observe four different criteria are being discussed with respect to parallel load. In all of them, master reset is equal to low. Now, PL is active low signal. Therefore, in all these four cases, PL is set equal to low value. Then after, why four different cases with respect to CPD and CPU we are going to make use. So with respect to CPD, when CPD is equal to low or high, and if we are keeping the data lines D0 to D3 is equal to low, then same values will be shifted to the output over here. Right? So if we keep some other value over here, for example, if you are going to keep 0001, the same value will be shifted over here. Right? Further, with respect to CPU, either CPU is low or high, keeping this PL is equal to low, whatever the value present on D0 to D3, the same value will be shifted over here. Right? So in this case, high is represented. So we can have any other value which is less than this high value. So for example, if you keep 0010, yes, that is good. So the same value will be shifted to the output. Right? So because when we are making use of CPU, this is what the terminal count, what we can thought about. So therefore, these values may be used. For the count up and the count down operation we are going to have. So in order to do that, first we have to disable both master reset as well as the parallel load operation. So master reset we are going to disable in the sense keep it equal to low. Parallel load disable in the sense keep it equal to high. Then CPU must be enabled. That means it must be given to the clock signal, and CPD must be compulsorily given to the VCC or to the high signal. Then D0 to D3 is of no use for us. Then the count up is going to happen at every rising edge of the clock. One count will be updated. Then countdown operation, again MR and PL will be low and high respectively. Then CPU must be connected to either VCC or to the high signal. Then CPD to the clock signal, again positive edge triggered. So D0 to D3 is of no use for us. Then countdown operation is going to happen. So at every rising edge of the clock, one countdown operation is going to happen. Again, just to remind, so TCU, TCD, PL are active low. Again, PL and MR are asynchronous in nature. Now let us just understand the same functional table in a very simple manner as a mode realization table. So MR, PL, CPU, CPD, and then we are going to have the mode realization. So if we can remember this table, then it is very easy to remember or to rewrite that complete functional table in a easy manner, right? So just go through this table. So when MR is equal to 1, so all other are don't care. So output will be set equal to 0, then 0, 1, 0, 1, then it is going to perform with CPU is equal to clock signal CPD is equal to 1. It is going to perform the upcount operation. Then it is 0, 1 CPU connected to the VCC and then CPD connected to the clock. It is going to perform the down count operation. When MR is equal to 0, PL is equal to 0, this is active low signal. Then CPU, CPD, we can consider it as don't care, and it is going to perform the preset operation. And then 0, 1, 1, 1. That means, so this is a parallel load operation. Parallel load operation that is also disabled. MR disabled. Clock signals are not given to the clock. Instead, it is being given to the VCC. Then there will be no counting operation. It will be hold at the state wherever it is. Right? Okay. So for any further discussion, since we are not going to make use of any cascading operation, so I'll be dropping these two signals, that is TCO as well as TCD. Only I'll be considering the input signals as well as these four as the output signals. Now let us start with the upcounting operation. So this was the truth table for the upcount operation. So terminal count, beginning count, it will be from 0, 0, 0, 0, and terminal count it is going to have 1, 0, 0, 1. So total only decade counter, that's what we can design from this one, or we can also call it as the BCD counter. So CPU is enabled in the sense it will be connected to the clock. Therefore, at every positive edge of the clock, there will be one counting operation. The other states will be like this. So PL parallel load, we have to disable it. Therefore, we are connecting that to VCC or to the value 1. Master reset has to be disabled. Therefore, we are going to connect that to the 0 or to the ground. Then CPD down counting has to be disabled. Therefore, it will be connected to the 1 or to the VCC. Then CPU up count operation we are going to perform. Therefore, this has to be connected to the clock. Right. So this is what the truth table. Now let us go through the IC representation. So here is the realization of the upcount operation. So with respect to the mode table, we are at this particular state, upcount operation, parallel load 1, MR0, CPU, clock up is enabled, and then CPD is connected to VCC, then upcount operation is going to happen. So this for the configuration. So we don't have nothing, we have nothing to do with this D0 to D3. Option is you can keep it connected and feed any value for that or set it equal to 0, or you can leave it as open circuit, doesn't matter. Right? So for the sake of easiness with respect to the hardware configuration, we can leave it as open circuit. We can leave it as open circuit so that the number of connections are going to reduce and it will look much simpler. But for the sake of continuous representation, I'm just keeping these values and set and given as can be set to 0, or you can leave it as open circuit also, no problem. Still it is going to work correctly. Right? So once again, so PL set equal to 1. Master reset, input is 0, CPD connected to VCC or 1, then CPU connected to the clock, and by default this is going to perform the upcount operation. So output can be observed from Q0 to the Q3. So Q0 is going to be the LSB and Q3 is going to be the MSB. Right? So sequentially it will count from 0, 0, 0, 0 up to its terminal count 1, 0, 0, 1 in a sequential manner. Now let us get into the down count operation. So down count in the sense it will start from the terminal count and it will move towards the 0. So terminal count here is 1, 0, 0, 1. So it is starting from this point and it is going towards the lowest value, that is 0, 0, 0, 0 in a sequential manner. For this we have to connect the clock as down counting, that is CPD. So CPD will be connected to the clock. Again, it's a positive edge trigger. So at every one positive edge triggered, one value will be updated. Therefore, from terminal count towards the lowest value, that's why we call it as a down counting operation, right? From terminal count towards the lowest value. Now the setup with respect to the input. So PL value must be equal to 1 or connected to the VCC. MR value to 0 or connected to the ground. CPU must be disabled. Therefore, it is connected to either 1 or to the VCC. Then CPD is the down count operation or the down count clock. So since we are making the down count operation, so this is what has to be enabled. That means it must be connected to the clock. Here is the realization. So with respect to the mode table, we will be performing down count operation. So these are all the configuration we are going to make use of, and the same is being represented here also. So it is PL is 1, master is set, input is 0. So CPD connected to the clock, CPU connected to the VCCR1. Then these are the outputs. So again here also, so data lines D0 to D3 may be connected, and you can keep it as any value. You can keep it at any value because it is not going to bother us, or you can keep it as open circuit, no connection at all for these lines, right? So in this case, now it is going to take the values from 1001 up to 0000 in a sequential manner, right? Okay, thanks for joining.